this. Today we're beginning chapter 2.2, which is on units of measurements. Our objective is that we're going to express and manipulate chemical quantities using scientific conventions and mathematical procedures. So like I was saying earlier, once you go from biology in your freshman year to chemistry in your sophomore year and then physics in your junior year, you notice that there's a difference. Biology is more of a natural science. Chemistry and physics is more of a physical science. And because they're more of a physical science, they do involve a lot of mathematics. So we are going to be doing a lot of calculations in class. And for that reason, I do want you to make sure that by tomorrow you do have a blank piece of paper, pencil, and a calculator. Again, hopefully you already have one for math class. If not, you can use the one in your phone, or I'll put a link for you to use one online. But make sure that you have that for tomorrow. So the vocabulary that we're going to be going on talking about today: volume, mass, height, density. Our essential question: how does the use of units and measurements make science more reliable? And we've already completed our quiz. We're going to move on to the lecture, and then we're going to complete, instead of the 2 gizmos that I have there, we're only going to complete the one for volume, the first one. And we're going to do the second one tomorrow because I don't want you to rush through the first one. And again, on that note, the gizmos are, the purpose of them is to help you actually practice. A lot of times in chemistry, the concepts are very abstract. They're hard to understand because it's things that you can't see. So a lot of times the simulations, the labs, help you kind of, oh, okay, so that's what they mean. So that's why it's very important for you to complete it. And I do want to say, as you guys are completing it, I'm able to open your document and I'm able to see as you're typing. And unfortunately, I did see yesterday that some of you didn't even type your name. Please don't start not doing the work, because that's only going to make you fall behind. And we really haven't done any chemistry right now. All we've done is science in general. When we start talking about chemistry, it's going to start to get harder and harder. So if you start getting in the habit of not doing the labs, not doing the activities, it's only going to hurt you in the long run. Please, I give you the time to do it during class. Just do it. Believe me, if you do what I'm asking you to do, you will be successful in this class and you will have a good grade. And that's all I'm asking you to do. And so for that reason, I don't give you homework because I don't want to overwhelm you. I don't want you doing this on your own and then having no one to help you. So please do the assignment in class. That's all I'm going to say. Okay, so let's go ahead and move on. If you notice in your notebook, this time around, I did remember to put the link to the PowerPoint presentation. If you want to follow along, again, just click on it. If it asks you to request access, go ahead and request it. When you close the window and open it up again, it should let you see the presentation. And as usual, you do have the notes and you're just going to be typing in the blanks, okay? So if you guys have any questions, let me know. If not, let's go ahead and get started. And here is our presentation for today. So, units of measurement, chapter 2.2. I already went over this information, so let's go over the specific objectives for this lesson. Number 1, you need to be able to distinguish between a quantity, a unit, and a measurement standard. Those are 3 different things. Even though they're connected, they're different. You should be able to name and use the basic units, the base units, and the international system of units, which for length, mass, time, volume, and density. We're not going to talk about density today. We're going to talk about it tomorrow. You need to be able to distinguish mass and the difference between mass and weight, because they're not the same, and be able to perform density calculations. Those we're going to do tomorrow. That's why I asked you to get paper and calculator for tomorrow, and to be able to transform a statement of equality into a conversion factor. And we're not going to do that until next week, actually. So those are the objectives for this chapter, this section. let's begin with units of measurements. So in your notes, go ahead and type it in. Measurements represent quantities. So a measurement is not the same thing as a quantity. It's always a representation of a quantity. For example, time. What measurements do we use to measure time? What units?
Minutes, hours.
Correct. Minutes, hours, seconds, days, weeks, years, right? All of those are measurements of the quantity of time. So time is a quantity, seconds, hours, days, all of those are measurements of that quantity. So that's what that means. Measurements are basically to represent that specific quantity, and you can represent time in those measurements. Second, weeks, days, hours, months, okay? So a quantity is something that has a magnitude, a size, and amount. So time is an amount, right? You can measure it in different ways, but it is something that we can measure. So anything that can be measured because it has a size and amount is considered a quantity. So I do want to emphasize a measurement is not the same thing as quantity. And I gave you the example with time. Time is a quantity and the measurement can be in many different ones depending on the size. Seconds, hours, minutes, days, etc. Right? Another example of quantity and measurement. For example, a lot of times we measure volume in teaspoons, tablespoons, cups, ounces. Those are all measurements of the quantity of volume. So in that case, the measurement is a teaspoon and the quantity is volume. We also use liters, milliliters to measure volume. So again, measurement is not the same thing as quantity. And last but not least, the choice of unit really depends on the quantity that you're measuring. For example, if we were here in school and I were to ask you to measure the length of the hallway, which unit would be better to use, or which instrument? A ruler or a meter stick?
Meter stick.
Correct. Why?
Because it's bigger.
It's longer, right? Since your quantity is going to be long, then you want to use the appropriate instrument, which would be the larger instrument, right? In this case, the meter stick. When I ask you, how old are you? Usually in what measurement do you respond? Years, right? You don't tell me, oh, I'm 1,256,000 seconds old. No, right? Because again, the quantity that you're measuring, in this case, your age, is more appropriate to be measured in years, right? That's what it means in the last statement. You always want to make sure that you use the right measurement for the right quantity. If you're going to measure, let's say, the thickness of your hair right here, would you use a meter stick to measure the thickness of a hair? No. No, because if you notice, the thickness of a hair is so small that really a meter stick this big is not going to be useful to do that. You would have to pick a correct measurement there. That's what it means. So raise your hand if you need more time on this specific slide. Okay, let's go ahead and move on. So we have a system of measurements that we call the International System of Measurements. In fact, it was labeled in French and it's called Le Système International de Units, which just means the International System of Units, and it's abbreviated SI. And this was basically the scientific community all over the world agreeing that we needed to speak the same language in terms of when we were measuring. Why do you think that scientists want to have the same measurements when they're doing their investigations? Why would I? Yes? Yes, Kene? To be more specific, you said?
Yes.
Okay. So yes, for example, let's say that I conduct a scientific investigation here in the United States, and I send it to someone in India, and then I send it to someone in England, and I send it to someone in Argentina. Okay, those scientists are going to try to perform the same investigation as me to try to prove that my results were correct. If the person in England is using inches, and then the person in India is using centimeters, and the person in Argentina is using kilometers, are the results gonna match? Are we gonna be able really to compare our results if we don't have the same type of measurements? Yes? No?
No.
No, right? So basically, scientists, when we're conducting investigations, we want to be speaking the same language in terms of our math. So we want to be using the same units. That way, everyone around the world can compare them and can get similar results. So for that reason, this was created. And again, it's called the International System of Units. And it has a total of 7 base units, meaning these are the most basic units, and every other unit is created from those basic units. Okay, so most other units are derived from these 7. And there's length, mass, time, temperature. Those are the most common that we're going to use and that you guys are familiar with. And then there's amount of a substance, electric current, and luminous intensity. Those last 3 are not as common. We're not going to talk about them that much here in class. So we're going to focus on the first 4 today, which is length, mass, time, and temperature. So raise your hand if you need more time here. Okay, I see a couple of you. I'll let you finish. Okay, make sure when you're done, lower your hand. Okay, next I'm going to be showing you a table that has the 7 base units, and you guys should have it in your notes as well. As I'm talking about it, highlight or add notes to it. That way you understand how we're going to be using them. So again, if you raise your hand and you're done, please lower it so I know I can move on. Okay, so here are the 7 basic units, and I had mentioned it before. It's length, mass, time, temperature, amount of a substance, electric current, and luminous intensity. And like I said, today we're going to focus on the first 4, length, mass, time, and temperature. Amount of a substance, we do use it in chemistry, in fact, but it's towards the end of the semester. So when we get there, we'll talk about moles. We'll talk about the amount of a substance. I'm not going to have you learn it right now because there's really no point, since we're not going to talk about it until the very end of the school year. So the last 2, electric current and luminous intensity, if you want to, I wouldn't say cross them out, but really those are more for physics. So if you want to put yourself a note next to those 2, when you get to physics next year, you are going to learn about currents, and you're going to learn about intensity for light. So those we're not going to touch at all here. Okay, so let's focus on the first 4. If you notice length, and you guys should be familiar with these, length, the symbol for it is lowercase l, mass, lowercase m, time, lowercase t, and temperature, uppercase T. Make sure that you write them as they're meant to be. If it's meant to be lowercase, put it as lowercase. If it's meant to be uppercase, put it as uppercase. Because if you notice, look at time and temperature. They're both T, but one of them is a lowercase t and the other one is an uppercase T. So there's a difference. So when something is meant to be lowercase, there's a reason. Write it as lowercase. Please don't change the uppercase, lowercase things, okay? Now, the length, the base unit for length is gonna be the meter, and it's abbreviated lowercase m. For mass, the base unit is kilogram and it's abbreviated kg. For time is the second and it's abbreviated S. And for temperature, it's Kelvin and it's abbreviated uppercase K. So those are the symbols for the quantity and the symbols for the units that you need to know. So those four really are the ones that you should be highlighting or that you should be making them stand out. Now, these are the base units. Sometimes you might have large quantities or small quantities where you might need different units. For example, for length, if let's say you were measuring a very long distance, you might have to use kilometers instead of meters. Or you might be measuring a small distance and you might have to use centimeters or millimeters. So we'll talk about that next week when you use the other units besides the base units. So any questions here? Obviously, for example, for seconds, for time besides seconds, if you have longer, you would use minutes, days, hours, or you could, if it's shorter than a second, it could be a millisecond, for example. And for temperature, you guys are familiar with degrees Celsius and degrees Fahrenheit, but the base unit is Kelvin. So make sure that you know those as well. Raise your hand if you need more time here on this table. Okay, so let's go ahead and talk about each one of these individually. We're gonna begin with mass. And mass is a measure of the quantity of matter. And we had talked about this already. So how much matter there is in an object is mass. And the base unit for mass is the kilogram. Okay, now make sure that in your notes, go ahead and put grams next to it, because a lot of times in chemistry, we're measuring the mass of very small quantities. And so instead of using the kilogram, we use the gram. Okay, so also put there grams as well. Now, mass sometimes is confused with weight. But weight is actually a measurement of a force, and it's the force of gravity, meaning how much pull does the gravity of a planet has on that specific amount of matter. And weight is always dependent on that gravity. So for example, if you are here on Earth, you have a specific weight because of the pull of gravity from the Earth. But if you were to go to the moon, for example, your weight would actually change because the gravitational pull of the moon is lower than the gravitational pull from the Earth. So you would actually weigh less in the moon because there's less gravitational pull. So weight is always dependent on gravity. However, mass never ever depends on gravity. I don't care what planet you're in. If you measure this amount of mass, it's always going to be the same mass anywhere you take it because it does not depend on gravity. It's just the amount of matter present. So raise your hand if you need more time on this slide. Okay. Again, make sure that you also add that the gram is often used, especially here in chemistry, because we measure small quantities. Okay. And before I move on, weight again is going to be, we're not going to talk about it here in chemistry. We're not going to use weight at all. We're only going to use mass. In physics next year, that's when you're going to be talking about weight, and that's when you're going to be using weight in your calculations, but not here in chemistry. Okay, so let's move on to length. Length is a measure of a distance. And sometimes we call it, also we can call it width or height, but they're all measuring the distance. And that is always measured in meters. That's the standard measurement for length. It's in meters. Sometimes you can have longer distances, and that's when we use the kilometer. Or sometimes you can have shorter distances, and that's when we use the centimeter or the millimeter. But the basic unit is the meter. Okay, so that's length. And again, sometimes we can call it height, we can call it width, but they're all measured in meters. Okay, raise your hand if you need more time on this one. Okay. Now, while you guys work on that one, because I know some of you did raise your hand, I will say we're not going to talk about time in the notes because I mean, you guys are familiar with time. You know what a second is, you know what a minute is, you know how it's used. So we don't even touch time. It's really not something that we cover here in chemistry. You are going to talk about time a lot more in physics, but not here in chemistry. So that one we're not even going to touch today. And temperature, since we're not going to be using it anytime soon, we're not going to cover it either. We'll talk about temperature when we get to gas laws, for example, where we do need to know the temperature of the gas, for example. And we'll talk about what a Kelvin is and how it compares to a degree Celsius and Fahrenheit. So today we focused on mass and length. Those are the two base units that we focused on today. So as soon as you're done, lower your hand so I know that I can move on. And I think something's happening with Jose because he keeps coming in and out. Are you having issues, Jose, with your connection?
Yeah, it kicked me out.
Yeah, I can tell. Bueno, if you don't catch the whole thing, I'll put up the video so you can watch it if you want to, okay? Okay, so again, lower your hand so I can know I can move on. Okay, so let's go ahead and move on to what we call derived units. And derived means basically units that are created from other units, and it's usually a combination of other units. So go ahead and write it down and then I'll explain. So derived units are combination of other base units, and here they give you the example of pressure. When we measure pressure, it's usually measured in kilograms per meters times seconds squared. So if you notice there, you're combining kilograms, meters, and seconds. And those are three different base units. So anytime you combine different units together to form another unit, that is what we call a derived unit, okay? And I'll explain this table right now. I'll give you an example first. So let me start here. Okay, so I'll come back to the table. So if you haven't finished, that's fine. Let me come back. So here, if you notice, I have a rectangle. Now, how would you find the area of this rectangle? If I ask you to find the area of this rectangle, how would you find it? What would you have to measure?
Length,
Width.
Correct, correct, very good. So we would measure the length, right, and the width. And what base unit did we say length is measured in? We just went and we just talked about length. Well, yeah, in this case, since it's small, it would be centimeters. But what is the base unit that we use for length?
Meters.
Meters, right? So basically, we would be taking meters times meters, right? What do you think we would get if we multiply meters times meters? What unit do you think we would get? Let me give you an example. In math, when you multiply x times x, what do you get?
X squared.
X squared. Well, the same thing is going to happen here. When you multiply meters times meters, what do you think we're going to get?
Meters.
Meters squared, correct. This is what we call a derived unit. Why is it derived? Because it's a combination of two base units. As soon as you combine two base units, that is what we call a derived unit. So the unit for area is a derived unit. Does that make sense?
So it could be the same.
Yes, it can be the same one. It doesn't need to be a different one. For example, for speed, because you guys are familiar with speed, I'm going to use that one. Okay, when you want to find speed, you're taking distance over time, right? And what unit do we use for distance? We said meter. And what unit do we use for time? Second, right? So the units for speed is meters per second. This is another example of a derived unit because it's a combination of meters and seconds. So yes, it can be the same unit here, like meters times meters, which gave that meters second, meters squared, or it can be different units like meters and seconds. As soon as you have two different ones here, it's also a derived unit. Yes. Any questions here? Let me give you another example. Okay. So let's say that you have to measure volume of this cube. How do you measure the volume of a cube?
The length times width.
Correct, right? So you have your length times your width times your height, right? And again, we agreed that all three of them are measured in meters, right? So basically I'm taking length in meters times width in meters times height in meters. So meters times meters times meters, which is going to give me, what is going to be my derived unit here? Meters times meters times meters. Yes, Kenya.
Meters cubed.
Correct, meters cubed. That is another example of a derived unit. Okay, so as soon as you combine a base unit with another base unit, even if it's the same one, you get a derived unit. So let's go back to the other examples that you have in your table. Let me exit here. Okay, so in your table, if you notice here, I already gave you the first one, the example for the area. Because you're combining length and width, you get a derived unit, which is meters squared. And when you are trying to find the volume of a cube, for example, because you're combining length times width times height, you get a derived unit of cubic meters. I gave you the example of the speed one, but then that one is not here because that one we don't use it in chemistry, but I did include density, which we will use here in chemistry. In fact, tomorrow we're going to use it. Molar mass, we're going to use that eventually towards the end of the semester. Molar volume and energy. We are going to use these derived units eventually. And if you notice, they're all a combination of base units. Like this one is a combination of mass and volume. This one is a combination of mass and amount of a substance. This one is a combination of volume and amount of a substance. And the last one is a combination of force and length. So those are derived units. Raise your hand if you need more time or if you have a question. Okay, we're almost done. We're gonna move on to volume. Okay, so we had already talked about volume, and volume is the amount of space occupied by an object, meaning how much space does this object occupy? And the base unit for this derived unit, this is a derived unit because it's a combination of length times width times height, like I showed you in the example, right? So that this derived unit is in cubic meters. You might also see it as cubic centimeters when you have a small object, like if it was a small cube, most likely you would measure it in cubic centimeters as opposed to cubic meters. Cubic meters would be like if I ask you to measure the volume of this room that I'm in. That's when you would use cubic meters. But if you had to measure the volume of something smaller, then it would be in cubic centimeters. Now, I'm talking about solids, measuring the volumes of solids. What about if you had to measure the volume of a liquid? How would you go about doing that? Okay, let me pose the question differently. If we were face-to-face in class and I asked you to measure the volume of a specific amount of water, how would you do that? What instrument would you use to measure it?
The beaker.
A beaker, very good. Another instrument would be a graduated cylinder. So thank you, Nedved. So do we measure the volume of solids and liquids the same? No, we don't. Solids, we talked about it. If it's a regular solid, it's going to be liquid length times width times height. But if it's a liquid, we're not going to measure it the same way. Hence, the unit is not going to be the same. When you're talking about liquids, most likely the unit is going to be the liter. And this one is not one of the base units for SI, but we are going to use it a lot here in class. So make sure that you start by it and put liquids. We always measure liquids in liters or in milliliters. So make sure that you highlight that in your notes or that you put a star by it so that you remember. Liquids are measured in liters or milliliters. Now, there's one third thing. Let's say that I wanted to find the volume of this object. Let me put it under the camera here so you guys can see it. Okay, so would I be able to find, how would I find the volume of an object like this that is irregular? Do you think that I could measure the length, the width, and the height and find it like that? Is it as simple as that? Just measuring length, width, and height? No, right? Why? Because it's irregular. Does anyone know how you can measure the volume of an irregular object?
By displacing water.
Correct, water displacement. That is one of the things that you are going to practice today in the gizmo. So in the gizmo, it's going to have you practice how to measure the volume of a solid, the volume of a liquid, and the volume of an irregular solid. So you're going to do all three. You're going to practice how to use a graduated cylinder, how to use a pipette, how to use a beaker, how to use a ruler to measure a solid, how to use a beaker graduated cylinder to measure irregular solid. So that's what you're going to be using for the gizmo. So let me go back to the notes here. So you are going to get a chance to practice that today, how to measure volume for those three different things. So raise your hand if you need more time on this last slide. Okay, and that's it for the notes today. The only thing I'm going to show you before I let you do the gizmo is these two videos. Okay, we're never gonna measure the volume of a gas in our class, so you're not gonna practice that one. You're only gonna practice the first three in the gizmo. And before I let you go on to that, more on how to measure liquids.
Miss,
Yes.
we're only gonna do one of them.
You're gonna do a gizmo and you're gonna practice how to measure a regular solid, how to measure liquid, and how to measure the volume of irregular solid. Yes, irregular solid. Okay. Can I continue?
Yes.
Okay. Okay, we're never gonna measure mercury, so don't worry about that one. You're always gonna be measuring liquids where you're gonna read the meniscus at the bottom, okay? So any questions before we proceed to the gizmo?
No, ma'am.
Okay, thank you. So let me show you really quick. In your Google Classroom, it's already there and it's titled Measuring Volume. So when you open it, you have the link and you have the document. So let me go ahead and open the link so you know what it looks like. And again, go ahead and use the same credentials that you used yesterday to sign in. Let me go ahead and sign in myself. And it looks like this. If you notice, you have different tools and you can actually move them from the cabinet back and forth. You can move the ruler, the pipette, you have a cube, you have a sphere, you have a marble, you have a rock, you have a magnifying glass. You can turn on, turn it off. Okay, so there's different things that you can do here. And again, the instructions are gonna be there for you. Go ahead and just follow the instructions. You are gonna do the entire activity. So every single section, let's look at it. It does have activity A, activity B, and activity C. So make sure that you complete the whole thing. If you notice here, activity A, activity B, and activity C. So make sure you do all three. The only thing that I won't ask you to do, because I found that it wasn't as simple as I thought it was, is here where it asks you to sketch. Don't worry about it. If you want to try it, you can. All you have to do is click here and then click edit, and it'll let you draw. But I found it very difficult, and since I couldn't do it, I'm not going to ask you to do it. If you want to try it, be my guest, but I'm not going to grade that part. Everything else I will grade. So any questions on what you need to do the rest of the period?
No, miss.
Okay, you have like 30 minutes left. That should be plenty of time for you to finish, and we'll do the other one tomorrow. So go ahead and get started. If you have any questions, let me know. I'll be here to help you.